Ladies and gentlemen, you might be wondering what that is behind me. Some of you are laughing. It's close to lunchtime, but I'm not talking about lunch or anything like that. It's just an avocado. And the avocado is a fruit with a pit, something like I have here. And that is the origin of a core of something with the primary form of the green transformation that develops something. And here it is a fruit that is delivering energy. And therefore it needs some prerequisites. And that is, on the one hand, it needs to have a fertile ground, it needs to have water, it needs to have the sun, and last but not least, it also needs to have some helping hands to let it grow. And it's the same with the H2 core grid. The H2 core grid needs some prerequisites to grow as well. It is, on the one hand, the ground, the fertile ground, that is that we have financial conditions in Germany that are attractive to attract all the international investors to bring the money here and build it. The second one, the water, is the people that we need to build the grid. The third one, the sun, would be the hydrogen that flows through the system. And the last one, the helping hands, are the people that take care of the grid and that do all the maintenance. And that is why you can see why I have chosen the avocado, because it's a core that is developing, and also the core grid that I would like to mention and explain here in my lecture is something that would like to grow and then serve for an energy system that will help to reduce or to meet our greenhouse gas reduction targets, and also to safeguard the location of the industry here in this country, as we have seen, for example, for Salzgitter. And that's, ladies and gentlemen, I would like to welcome you to my presentation that is indeed about the H2 core grid as a Kickstarter for the hydrogen economy in Europe. Everybody is talking about the so-called chicken and egg problem. And here the chicken and egg problem means, on the one hand, nobody invests in the production of hydrogen if there is no downstream pipeline system to transport the hydrogen to the customer. And on the other hand, no pipeline system will be invested if there is no H2 production. And the H2 core grid is an assumption or is an approach to overcome this problem and to solve this problem. And the good news that I can give you, the H2 core grid modeling in Germany has already been completed. And maybe we can zoom that in a little bit, then we will see in a kind of nice animation how the system should be developed. And at the end, what you can see here are 9,700 kilometers of nice hydrogen highways. This grid has been published, it has been consulted, so it's not just an idea of the TSOs, of the network operators, it just has been designed in that way in the topography to serve the customers and also to serve the needs. It will be good for 400 terawatt hours of hydrogen supply, and that is 90% of the capacity of the grid will be filled to secure all the supply and demand in Germany in 2035. Or in other words, 240 terawatt hours is approximately 30% of the natural gas demand that we have so far today in Germany. If you want to have more figures, it's 87 gigawatt exit capacity, so 90 big power plants or something like that. There is more good news about this story here, because different things have already been done in the recent years to make this happen in future. And I would like to name the first thing here, that is that all the technical regulations from the DVGW in Germany are already H2 ready. That has been done in recent years. Second one, the H2 suitability of the assets has been proven. That has been proven by our own engineers, that has been proven then by certified external experts as well, so that we know most of the pipelines can be converted. And I forget to mention that this grid here consists of 60% sustainably converted pipelines, and we can do that. The other rest, the remaining 40%, will be new built pipelines. Then many people are talking about the quality of hydrogen. Here I can say in current negotiations, we have found out that 99.5% of hydrogen can be guaranteed in the pipeline via we transport it, or even in the used pipelines. That is also a very good sign. That is not being in the technical regulations officially so far, but it will be very soon. Then we went ahead because I'm personally convinced, we always say the success of our companies depends on our people. And that is why we have to invest in our people, and that is what we're doing as well. So we have developed special trainings, theoretical trainings on hydrogen that we offer to our own people, also to third parties. But that is not all, because we have to get all the paragraphs in the theory into praxis. And that is the reason why we, as OGE, have decided to spend 10 million euros in a training loop for hydrogen in the eastern part of the Ruhr area. We're having a high-pressure loop, a low-pressure loop, where you can do all the trainings for new build, for maintenance, for releasing hydrogen, for whatever you would like to do. So that is all prepared. And then we're having pilot projects as well. I would like to mention two here. One was a nice project where we have tested in existing gas turbines that we can feed them with 25% fuel gas with hydrogen. That really works, so that is kind of H2 readiness there as well. And we have just started as the first TSO, OGE has started in the northern part of Germany, the conversion of a high-pressure pipeline from natural gas to hydrogen. So all that is going on, and you can see we are really serious, and you can see that the diggers are already waiting for the core grid. They are already warming up. Next number here is the CapEx. Why do I show CapEx? You might be wondering that 20 billion euros is a lot of money. Yes, indeed, it is. But if you compare it to the 300 billion euros that are necessary in the German power grid until 2045, and then for the same amount of energy, this system here is capable of transporting the same amount of energy as the electric power system, then 20 billion euros is just really a fair and efficient investment in comparison to that what we have to do in the energy turnaround. We want to start very soon. It's the first half of 2024 because we have prepared everything, but we have to find the financial framework for it. We are working on it with the German government. We are in very positive negotiations in the last months. We did that together, but we are not done yet. I have to say that we are not done yet. Then this all should be finished by 2032. That fits very well here to the time schedule I have seen from Salzgitter as well. And that is also a very big challenge. And I would like to say that 2 years ago, me and my team, we were participating, one of the protagonists, in the new German speed when we connected the LNG terminal in Wilhelmshaven in less than a year. But I know we're having a very tight market, and also with all the permissions, the authorities and so, it will really be an issue to do that until 2032. But we are ready. We want to do that. Then, if we have this core grid here, that will be one of the basic pillars of the climate-friendly energy system of the future. Besides the renewable green energy, we need the hydrogen as the ideal partner with the possibility to transport huge amounts of energy and also to store huge amounts of energy. But that is not all. We will have to import green and blue and whatever hydrogen to Germany to fulfill the supply gap that we will be having. And also our state, our government is already up-road securing energy, establishing energy partnerships to secure energy supply to Germany. And we're having different corridors here. I would like to mention some of them. For example, the North Sea corridor. The North Sea corridor will be good to import blue hydrogen from Norway. It will be good to import green hydrogen from a renewable production in the North Sea. Then we will have to import, that is also for sure, different derivatives of hydrogen via ship. That could be to Belgium, to the Netherlands, that could be to Wilhelmshaven or any location as well. That could be ammonia, that could be SNG. So we are open for that as well. Then we are having the next corridor here is the Iberian corridor. There will be renewable production here in Portugal and in Spain, and then via the so-called H2Med project. Maybe you have heard about that. We are participating in that as well. Hydrogen can be transported to Germany or Western Europe as well. And some more corridors I would like to mention here, the Nordic Baltic, the Eastern, the Southeastern corridor, and the Adriatic corridor. They are all have their origin in countries where there's a lot of potential for renewable H2 production. And we will all use them. We have projects associated to all these projects. For example, for the Eastern Corridor, we had 2 really good defined projects before the terrible Russian war of aggression. And I'm really looking forward that we can keep up speed in all these projects in future as well. So once we have the core grid of hydrogen, once we will be connected to Europe, is the question, is that all that we can do? And I think it's not really all. We have to do more. And the next slide here is showing how I think the future should look like. It is for sure that we need natural gas. But taking into consideration the greenhouse gas reduction targets of Germany and Europe, we have to phase out of the fossil gases until 2045. The second pillar then will be hydrogen. I have mentioned that is for sure. But that is not all, because in the industry there will be unavoidable CO2 emissions, and we have to take care of that one as well. And that is the reason why the third part here in the triangle is CO2. We have to establish a carbon management as well. And carbon management means we have to treat the unavoidable CO2. It is estimated to be 10% of the German CO2 emissions, and we have to take care of it in terms of CCS and CCU as well. And we as OGE, we have the natural gas grids that could be converted to hydrogen, and we have the knowledge as a pipeline operator, and we think we are very well prepared to establish a CO2 grid in Germany as well. So that all sounds quite promising, but I have to point out the final investment decisions for the core grid is not yet been done. So we are in the negotiations with the government, and especially with the Ministry of Economics and Climate Protection, with the Finance Department, with the Chancellery. The last months were very challenging. They were very positive, and I hope we can do it until the 21st of May. That is the date that everybody has in his mind, where we can file an application to be part of the core grid together with the other TSOs. And once we have that, the core grid should be followed by a regular planning procedure that combines natural gas and hydrogen. It is at least important also for the pipelines to be converted. And then we have to include the DSOs, and we have to include the storage operators. It's very important because a lot of energy is connected to the DSO grid, and we need the storages in order to secure supply also when the wind is not shining and when the wind is not blowing and the sun is not shining, pardon me. So, as a last word, let me say we all have to work together that at the end, this pit here again from the avocado or the core grid can bear fruits to secure our energy supply. Thank you very much.
Yes, thank you, Thomas, for your very illustrative presentation also. I mean, of course, we are curious now. You talked about the financial negotiations with the government, so the financial framework being one of the core requirements or ingredients for growing that project, make it successful. Can you give some information what is needed in the financial framework so that the project can become real?
Yeah, the investment framework in Germany is such as that we have more than 300 billion investment opportunities in the electricity, in the power sector, just in the grid, not talking about power plants. We're having in the district heating about 50 billion, and then we're having this 20 billion here. That means it has to be attractive for the people to go to Germany and spend the money for hydrogen. The return on equity is the one thing that is currently being equal to that one in the electricity sector. But then there is a huge self-retention once the ramp-up of the hydrogen fails. And that is really a problem because people can choose whether they can invest in the electricity sector or in the hydrogen sector for the same amount of equity return. But then you have the self-retention in the hydrogen, and that's kind of a problem there, yeah.
Mm-hmm. Okay, so we keep the fingers crossed that everything will work out fine. How much pressure are you talking about when talking about a high pressure pipeline in your presentation?
If we talk about natural gas, I'm talking about 100 bar. So onshore, offshore, you will have double 220. I think this is related to the hydrogen pipelines. It will be a little bit lower, up to 80 bar. So most of the new build pipelines are designed for 70, 80 bar in the hydrogen sector.
Okay, thank you. What would you say, who will take care and finance the connection of the more than 60 gigawatt CHP capacity, as most of the CHPs are most likely not close to the FNB grid, and the distribution grid operators are not part of the core grid?
Yeah, that's a very good question, because as I have said in the key takeaways, that has to be designed, or that has to be decided on. Once we have the core grid, and yeah, let's keep the fingers crossed that we have it in a few months, that we started, then the process will start where the DSOs can tell their demands in their region, and then it has to be found out who does this connection. That depends on the size of the parameter, whether it is more a TSO or a DSO project. And then you have to find someone again to spend the money, and that has not been decided so far. Could be the TSOs, could be the DSOs. Sorry, no clearer answer now.
Okay, so we'll see where we'll be going. Maybe there's a supplier here asking that question. Do you see the necessity, or at least feel an interest, for barrier layers, if not for the pipelines themselves, but at least for connectors, pumps, fittings, nozzles, etc.? So protection, basically.
What is he meaning with barrier layers? If
so I think it's kind of coating, I would think, for the well, material that's being
so in general, as I have said, all the technical regulations are already written. So the safety and security concept of hydrogen pipelines is very close to that one of natural gas pipelines. And you all know as a supplier what we need there. It's probably exactly the same.
Okay. So when are pipelines going to be fully constructed and modified for the hydrogen grid? I think you gave your timeline with the phases.
There is a timeline behind it. You have seen the grid. We are currently starting with the first conversion. The first pipelines should be ready by 2026. That will be the RWE Lingen site will be connected from the Emsland to the Ruhr area. Then we will proceed to ThyssenKrupp facilities. That will be then done by 2027, 28, and it goes to the Frankfurt region, and everything should be done by 2032. So that's roughly. Okay. If you want to have more details for every pipeline, there's a certain commissioning date.
And who builds the pipelines, and when is a business case given investing in pipelines?
Yeah, so building the TSOs, we would build it. So it's not only OGE, we are 12 TSOs in Germany, and we would build the pipelines and the core grid. And with the companies that all of you know that are here as our subcontractors that are ready, who would be investing? It is the TSOs first, and then our shareholders. And these are the people that are currently looking over all the contracts, whether they do it, whether they make the final investment decision or not. And that's basically what it is. Yeah.
Okay, good. You talked about, I think it was the 25% H2 readiness of gas turbines. What gas turbine did you use when you ran your test?
It was a Solar Titan 25 megawatts in White House.
Good, clear answer to this one. How much does the transportation of H2 reduce the CO2 benefit? Is it still a net positive outcome?
Yeah, the transportation of the H2 will be, so I have to explain, there will be compressors, and they will be fed with green electricity, so that there is nearly no emission in the transport of the hydrogen. So all the CO2 that you save in the applications is fully there. There's nothing you have to calculate against.
Maybe a last question. I found very interesting that you talked about also the CO2 network. How concrete is that? Are there potential customers already in the pipeline, so to speak, for such a network?
Yeah, that is really amazing, because I feel if we ask for the demand in the industry, there's a lot of demand for CO2. It's accelerating more and more. We're having a first project in the Brunsbüttel area where we are already in the engineering. We're having many customers where we are talking with, and no final investment decision yet, but it's really ramping up very quickly.
Okay, very interesting. Thank you very much for your presentation and your insights.